morning everyone. I am here to record a lecture on electronic devices, and the first lecture is Introduction to Semiconductor Physics. As we can see that semiconductor physics is a part of electronics and it has numerous materials in it like third group elements, fifth group elements, fourth group elements and so on. So, what we are going to deal in this lecture is about the different type of materials, the third group, fifth group and fourth group materials, and the compound semiconductors, and what are elemental semiconductors, and how we will use these semiconductors to construct a laser, a LED or a detector. So, this is a detailed syllabus of the electronic devices. The first one is the Introduction to Semiconductor Physics, which I am going to deal with in this lecture. So, it has Introduction to Semiconductor Physics, review of quantum mechanics, electron in periodic lattices, EK diagrams and so on. In the second unit, we will cover the same thing like energy bands in intrinsic and extrinsic silicon, how the carrier transport equations are there, how there is drift current and diffusion current flow in the case of the semiconductor, what is resistivity, sheet resistance, design of resistors, etc. In the third unit, correspondingly, we will see how the generation and recombination of carriers will occur, how the equations will evolve in the form of Poisson and continuity equation, what is p-n junction characteristic, and how the switching models will work in the case of the p-n junction characteristic. In the fourth unit, what we will going to cover is avalanche shift breakdown, because there are numerous kind of diodes which we have to deal in the case of the semiconductor physics also. So, there are avalanche diodes, Zener diode, Schottky diodes and junction transistor, and there are bipolar junction transistor, IV characteristics, Haber-Moll models, etc. In the last unit, what we are going to cover is MOS capacitor, the MOS CV characteristic, MOSFET IV characteristic, small signal model and some of the semiconductor devices like LEDs, lasers, photodiodes and solar cells. So, in this picture you are seeing like there are various kind of electronic devices, the gun diode, LED, pin diode, step recovery diode, laser diodes, Schottky diodes, Zener diode, tunnel diode, varactor diodes and so on. So, these diodes are basically made from the different compounds of the semiconductors. We can use gallium arsenide, we can use indium gallium arsenide, we can use aluminum gallium arsenide or a quaternary compound, that is indium gallium arsenide phosphide. So, these are the devices we have to deal it with in the case of the semiconductor physics, and these are various important devices like gun diode is used in microwave and it can be constructed with the help of the semiconductor material like gallium arsenide. The laser diodes have different functionality like spontaneous emission and stimulated emission, we will deal into it. The LEDs, which are light emitting diodes, has only the spontaneous emission, the pin diode, the step recovery diode, and there are different avalanche breakdown and Zener breakdown diodes are also there. The varactor diodes, the tunnel diodes where there is a tunneling effect. So, these are all kind of electronic devices which we will use in the labs also and in the formation of a particular microwave devices and different LED lights and laser diodes and all. So, here we can see that the introduction to physics, the basically electron is what? Electron is a branch of physics, it is a branch of physics and it deals with the electron is presenting in the valence shell and it deals with the atom. So, what is atom? Atom is the smallest part of the material and the valence shell is basically energy levels inside the atom. So, as we know that there are multiple energy levels in a valence band, also there are multiple energy levels or you can say discrete energy levels in the conduction band. So, the electron or the atom movement from the valence band to the conduction band is through the excitation of a particular energy inside the valence band. So, what we are going to hear that valence shell is present in a particular atom, and what is valence shell? Valence shell is energy level inside the atom And what is atom? Atom is a particularly smallest part of the material. So here we will construct a semiconductor device or a semiconductor material, you can say a structure. So in the structure there is a fashion of atoms or a order of atom which is to be repeated again and again. So on the basis of that we have to discriminate different atoms in a category of crystalline, amorphous or a polycrystalline semiconductors. So we can see from this figure that atom are the smallest part of the material. Combination of atoms result in formation of material. Atoms will form the material by interaction forces between them. There are two types of forces which occur in the inside the structure between the two atoms. First one is the centrifugal force. This is the first force, and the second one is the centripetal force. So the centripetal force is towards the atom or the nucleus, and the centrifugal force is away from the atom or away from the nucleus. So there are two types of forces which binds the two atoms inside the structure. So we have to deal with that how the atoms are binded in a structure, in a lattice, inside a particular crystal, in a form of crystalline or in a form of amorphous or in a form of polycrystalline. So here in the semiconductor physics, crystalline structures are very important, because in a crystalline structures the atoms are arranged in a regular fashion. They are arranged in a particular periodic fashion. There we can find easily the periodicity of the structure. But in the case of the amorphous or in the case of the polycrystalline, we cannot do like that. In the case of the amorphous, the atoms are randomly ordered, and they cannot be, we cannot find the forces between the two atoms easily. In the case of the polycrystalline, there are some regions of atoms which are arranged in a regular fashion, other regions are arranged in a regular fashion, but not the complete entire lattice is arranged in a regular fashion. So particular area is arranged in a regular fashion. So in semiconductor physics, what we are going to see that the crystalline structures are very important, because by the proper arrangement of the atoms inside the crystalline structure, we can easily find out the value of the centripetal or the centrifugal force. So next, coming to what holds electron in an atom. How can an atom will be inside a particular nucleus. So the forces are present inside the atom which hold electrons, protons, neutrons inside the atom. As I have told you that these are centripetal and centrifugal forces which acts towards or away from the center. That is nucleus of the atom which will be hold in the electron in the atom. So electron is basically a negatively charged particle which has a value 1.6 into 10 to power minus 19 coulomb. So what is material? So as I have told you that we have to design a semiconductor material, or we have to create a semiconductor material. It can be of gallium arsenide type, it can be of aluminum gallium arsenide type, and a quaternary semiconductor, indium gallium arsenide phosphide. So these are some ternary and these are quaternary compounds. So before this I want to tell you that silicon and germanium, these are some elementary, these are called elementary materials, elementary semiconductor materials, and these are compounds. So what we are going to see here, that how this gallium arsenide, aluminum gallium arsenide, indium gallium arsenide phosphide will contribute in a particular arrangement of a particular crystal, or how we can form a particular semiconductor material. Either it can be a LED, it can be a laser, or it can be a detector, it can be a pin or avalanche photodiode. So with this particular semiconductor elements, or third or fifth, we can have, you already know that gallium and arsenide, gallium is a third group and arsenide is a fifth group element. Similarly, aluminum gallium arsenide is a third group and fifth group element compound, and indium gallium arsenide phosphide is a third group, fifth group compound. So with the help of third and fifth group, third and fifth group, which are very important. So third and fifth group will contribute to compounds of semiconductors. So, with the help of third and fifth group, we can find out various compounds of semiconductors which can be used for LEDs, which can be used for LEDs, which can be used for lasers, and which can be used for detectors. So, these three can be formed with the help of gallium arsenide, aluminum gallium arsenide, indium gallium arsenide, phosphide, and so on. So, on the basis of classification of material, we have divided the materials into three types. What is these? The first one is the conductor, which conduct electricity completely. For example, metals like aluminum, copper, etc. These are called conductors. These have a lesser energy band gap. Semiconductors which will conduct when external forces are there, external conditions has been created, like there will be a change in the temperature or ambient pressure, or there will be some excitations. So, for example, silicon and germanium. So, I have told you that silicon and germanium is an elemental semiconductor. Next is the insulators, which do not conduct at all, for example, rubber, plastic, wood, etc. So, on the basis of semiconductors classifications, we have their energy bands. So, there are two types of energy bands, we already know, that is, first one is the valence band and the second one is the conduction band. So, but we can see from this diagram that there are splitting of the band inside the valence band and inside the conduction band. So, we have splitting of the bands inside the conduction band or also inside the valence band. So, there are discrete energy levels in valence band, also discrete energy levels in conduction band. Also, there is a metastable state we can see, and it also have some discrete energy levels. So, with this diagram we can see that from the energy band 1, or we can say it is valence band, this is conduction band, and this is intermediate state. Or metastable state. So, it has also have the numerous or the splitting of the bands here. So, these are called band gaps. From the energy band 2 to energy band 3 there is a band gap, from the energy band 1 to energy band 2 there is a band gap. So, what are insulators are basically which does not conduct any electricity, and these are rubber, plastic, wood. So, on the basis of the classification of material, we can easily see that semiconductor materials are very important, because they conduct electricity on the excitation or changing the temperature, changing the doping concentration. We can easily conduct them, or electricity will easily flow into it. So, energy levels, level at which charge carriers resides having some energy. Energy band is basically combination of several energy levels. Band gap is mandatory so that the carriers will jump to and results in a particular conduction. If there is nothing a jump like there from the valence band to conduction band, there is no flow of energy. So, it's required that there will be a jump of atom from here to here, from valence band to conduction band, or we can like this. So, there must be a jump, and this can be happen only with the excitation of a particular light. So, when there is a jump, there is a flow of excitation of energy to a particular valence band. Also, when there is a fall, there is release of energy. So, there are two kinds of phenomena which we can see in the case of the lasers and also in the case of the LEDs. In the case of the laser, we have two phenomena, like the first one is the stimulated emission, and the second one is the spontaneous emission. In the case of the laser, because laser is light amplification, stimulated emission of radiation. So, it have both the phenomena. So we have the electricity, conductivity of the electricity only when there is a particular band gap between the two energy levels. In the case of the insulator, there is overlapping of bands, and then in the case of the metals, there are just lesser band gap, very less, negligible band gap. So there is no less conductivity of electricity in the case of the insulator and less conductivity in the case of the metals, but in between that there is very particular good conductivity in the case of the semiconductors. So the next we have the types of energy bands, which I have discussed already, that is valence band and conduction band, which consist of valence electron valence band, conduction band which consist of conduction electrons. Energy gap is basically separation between the valence band and the conduction band. So we can see from this figure that there is a forbidden energy gap between the valence band and the conduction band. Energy level is in electron volt. We will measure energy level is in electron volt. There can be multiple metastable states in between the valence and the conduction band. So the next question is, why silicon semiconductors are best choice? So as we know that silica is present in a form of sand, silica present in sand is called silica. Silicon present in sand is polycrystalline in nature. It has a regular arrangement at a particular region of the crystal structure, at a particular region of the lattice. To design electronic devices, polycrystalline silicon is converted to monocrystalline or silicon crystalline silicon. So single crystal silicon or polycrystalline silicon is the major thing which we can use here for the formation of the semiconductor devices. So now next is the charged particles. So how the charged particles are there? We know that semiconductor device have both the polarity, that is it has electrons also and it has holes also. So what is the difference between electrons and holes? As we know that electrons is negatively charged particle, holes are positively charged particles. Electrons have physical quantities which actually move, and holes, they are vacancies which is created by the movement of the electrons. Their movement result in flow of the current, electron movement, and holes movement results in the depends upon the electron movement. In the case of the electron, they move in opposite direction of the current. As the current moves, they move in the opposite direction. For the holes, they move in the same direction as of the current. So these are the basic differences between electrons and holes. So next, which is very important, is about semiconductor devices. How we can use these devices for formation of these particular LEDs, lasers, detectors and all, and what are the properties of semiconductor devices which make it best suitable to design these devices. So first is, it has the property of enhancing performance, reliability, cost effectiveness, and it can be used in a both way, like it can be used as an energy system or it can be used as an information system. What is energy system? Energy system is generation, distribution and regulation of a particular energy. The second one is the information system. So it can be used as an information system, it can process, store, communicate inside the particular crystal or inside the particular arrangement of the atoms. So it can easily store, process, communicate information. So semiconductor devices has vast applications. So what are the properties? As I have told you that it has both the polarities. Instead of, in the case of the metals or in the case of the insulators, they don't have both the polarities. In the case of the semiconductors, we have both the polarities. It has positive polarity, that is holes, and the negative polarity, that is electrons. The concentration of charge carriers, which is very important, the concentration of charge carriers has in the range has a vast range, that is from 10 to power 16 to 10 to power 22. But in the case of the metals or in the case of the insulator, this range is not very vast. So it can be used in various applications. Like I told you earlier that with the help of the semiconductor we can form a gun diode, or which has a application in microwave devices. So The second point, which is the concentration of charge carriers, because it has a wide range of concentration of charge carriers. What is concentration means? The number of charge carriers per unit volume. So, it is concentration of charge carriers, which is number of charge carriers per unit volume, or we can say number of holes per unit volume in a valence band, or number of electrons per unit volume in a conduction band. So, this will give you the concentration of the charge carriers. So, the concentration of charge carriers lies between 10 to the power 6 to 10 to the power 22 per centimeter cube. So, that is why it can be used for various applications. With the help of the semiconductor devices, we can make gun diode, which is a basic microwave device. The third point is the transport of the charge carriers, where we have two types of currents. First one is the drift current and the second one is the diffusion current. So, what is transport of charge carriers? We can see that inside the PN junction diode or inside the semiconductor devices, there is the transition of the charge carriers from N side to P side or P side to N side. So, there are two types of currents flow, which is basically known as drift current and the diffusion current. So, this drift and diffusion is present only in the case of the semiconductors. In the case of the metals, we have only drift current, not the diffusion current. The last one is the interaction of semiconductors with electromagnetic field. We have this semiconductor can be easily varied with the help of the electromagnetic field. We can create an electromagnetic field inside around these semiconductor devices. So, in semiconductors, I have briefed all these things. In semiconductors, we can have both positive polarity and negative polarity. This point is very important because it has both positive and negative polarity. That is one big difference between the semiconductors and the metals. The concentration of the charge carriers in semiconductor varies from over almost 15 orders of magnitude, that is from 10 to the power 6 to 10 to the power 21 or 10 to the power 22. So, these 2 points are very important for the use of the semiconductors in a particular vast applications, like we have used in this present scenario. We are different type of microwave devices. All these devices can be used, can be formed with the help of these semiconductor devices. So, in semiconductor devices, we have several ways of transporting charge carriers. So, there are drift current, diffusion current. So, drift current basically is the transport of carriers because of the potential gradient. So, this point is important, that is because of the potential gradient difference, there is a transport of carriers, or the electron and holes will move towards each other, and they have potential gradient equations. So, the next one is the diffusion current is the current because of the concentration gradient, and the last one is the thermoelectric current, the current flow because of the temperature gradient. So, these are differences between the drift current, the diffusion current and the temperature gradient. Thank you. So, in the next lecture we will see how these semiconductor bands will form and how these drift current, diffusion current and thermoelectric current will be there in the case of the semiconductor devices.